Okay, I'm back. We're going to continue on with our vector stuff. So we've talked about unit vectors. We've talked about the algebraic and geometric. We talked about different ways we can name them. We're going to, again, continue on with the nomenclature and the kind of depth of understanding and the language that we're going to need to use. So we're going to talk, excuse me, about parallel vectors. And let's more than a little self-explanatory. It really is self-explanatory. However, I'm going to just kind of get it down as a note. So we're going to have parallel vectors. And thing about parallel vectors is that they may have the same direction, or if you think about it, parallel just means, kind of like vert and vert. Well, if we had, let's pretend they were actually parallel. If we had one going this way and then this way, they'd still be parallel, right? So I'm not going to keep those there. I'm going to do better ones in a second. But they can have the same direction or the opposite direction. Okay, so that would look like, grab a vector here or over here, I guess. I like blue. Is that blue? I think that's blue. So there's a vector, and then if I come along here and say, certainly if I clone that guy, that's going to be parallel. But not only that, if I do this is why I do this in Smart Notebook, because it's really pretty much designed for this. That one is now parallel as well, in spite of the fact it's in the exact opposite direction, right? So these two are parallel because, I mean, they're clones of one another, and this is a clone as well, but it's going the opposite direction. So those are all parallel vectors. Okay, so those are parallel vectors. On we go. This color, whatever color that is, probably the same one I've used before. And there's also going to be equal vectors. And again, very self-explanatory. Equal vectors mean they have both the same magnitude and direction. Okay, so same magnitude and direction are to make equal vectors. Awesome. Now start actually getting into a little bit of mechanics. Let's look at vector addition. And for now, we're going to look at geometric vectors here. And so geometric vectors are the ones that are actually, physical and drawn on, as opposed to algebraic vectors. And algebraic vectors, that doesn't say vector, oh my goodness. Algebraic vectors are the ones that look like ordered pairs, or when we get into three space, ordered triples. Let's actually get the right word in there, hokey. Back we go, geometric vectors. Lovely. All right, so vector addition. Get out of the way. What we're going to do is I'm going to draw a couple of vectors here, and where this, well, it is, we're going to have assessment based on this. We need to do our best on the smartboard. It's really, really easy, or on the smart notebook, to get things parallel and the right length and everything like that. We would actually try to use like a ruler for measurement length here and do our absolute darndest to make sure that the directions are the same when we're doing addition. So imagine I have the following two vectors. All right, so let's grab this and we'll make one this color. So I'm going to call this, there's that vector, and grab a different color here and make this one like this. And so I am going to label these things. This is going to be vector U. Ooh, I don't like that. And I'll call this one vector V. So if I said calculate u plus v. Here's what we do. With u, you would, get this out, you'd measure it, and you'd, draw it again, or something else. Here, I'm going to show you. So I have the luxury of being able to say, okay, I'm going to take vector u, I'm going to make a copy of it. I'm going to go put it over here, just so I've got a workspace. And I'm going to take vector v, and I'm going to copy it. I'm going to clone it, actually. And I'm going to move it. Now, vectors get added head to tail. Okay. And so that is vector u plus vector v. And the answer, and I'm doing air quotes even though you can't see me, the answer is called the resultant vector. And the resultant vector starts from the same place as the first vector and ends at the same place as the second vector. Okay, so this right here is, I don't know that color there. I'm going to go with R vector because it is known as the resultant vector. Okay, so the resultant vector is the sum of those two things. So u plus v is going to be equal to vector R, which I call the resultant vector. Now, you might have asked yourself, how do I know which vector goes first? Interesting question. Look, there's something called the parallelogram law of addition, and I think that's silly, even though it does make a parallelogram. It's just kind of obvious, because if I added this vector and then I added this vector, it's going to take me to the same place, right? So it doesn't matter what order I add in. Now, addition is unique in that, just like we know that 5 plus 6 is the same thing as 6 plus 5. Addition, that makes sense. Clearly, that doesn't extend to subtraction, nor does it extend to vector subtraction. Now, it gets kind of interesting. Some of you may already know this. When I don't want to talk about vector, I'll leave that there. Vector multiplication yet, because there's more than one type of vector multiplication. So when I say multiply vector u and v, that is not a distinct statement. It does not tell me exactly what to do. Later on, very soon, we're going to learn that there's two types of multiplication of vectors. There's dot product of vectors, and there's cross product of vectors, and they're both known as vector multiplication. But we'll get there. For now, when we calculate addition, it doesn't actually matter the order that they go in, as long as we add them from tail to head and vice versa. So here we go, and there it is, and ends up there. Now notice the resultant vector starts where the original two vectors started, and it ends where it ends off. So that direction is important. So if you're doing an addition, you actually have to draw the head of the vector in, because that tells me where it is headed towards. You don't need the dot on the end of your vector like that by any means. Typically speaking, vectors will just be drawn more like this, right? So that's normally what a vector would look like. I just think it's kind of fun to have the dot on the end, but that's not a requirement. There we go. So that is vector addition. It can occur in any order. Okay, lovely. Now, let's get into the more challenging one, and I'm going to talk about vector subtraction. Ooh, stop that. Well, I want a pen. All right, so let's go with vector subtraction. Now, vector subtraction is an interesting one. There are some weird rules that go along with vector subtraction. So imagine I'm going to take those same two vectors. I'm actually going to grab all this stuff. I'm going to clone it, move it down. So I'm going to take these same two things. You can probably just use it on the same page because you can see everything. I can't. So I'm going to copy that and then put it down here. Can I put it like that? I can. Yay. Awesome. So there it is. It kind of makes me feel like a little bit more like being back at school again using Smart Notebook. Okay. Have I told you guys I miss, interacting with everybody? I really, really, really do. Like a lot. Just had a nice conversation with Mrs. Whitty tonight, and we talked about that I had just started into vectors, and she was pretty stoked. Yeah, so am I, and I miss everybody. Except you, Jed. I miss you the most. No, I don't. Okay, here we go. So vector subtraction. Imagine that I wanted to do vector u minus vector v. So imagine I want to do, I'm not on the pen. There we go. U minus v. Okay, I want to do u minus v. Now, I'm going to show you how I would always encourage you to do it. And then I'm going to show you another way that it can be done, although personally, I'm not a big fan of that. Okay, so u minus v can equally be written as u plus negative v. Now, what does negative on a vector do? Well, it turns it the other direction. So I'm going to pull out, I'm going to make copies of these guys. Oops, no, I'm going to make this. I'm going to make a copy of this. And no, I want to make a copy, I want to make a clone of it. So there's my u, and it's supposed to be how it is. I'm going to take my v, I'm going to clone it. I'm going to bring it out. Now this is v, okay? But I want negative v. So I'm going to switch the direction of this. There it is. So this is now negative v. So this is u. Oh, give me a pen. This is u. And this is negative v. And what it says is we get to add these guys now. Order doesn't really matter. Lovely. So I'm going to take this and make sure I've actually got this. And I'm going to add them. And tip to tail. And so the resultant vector here, I'm going to go with just this guy and make it this color. So the resultant vector is this. Now I'm going to just get this down here. Oh, no, okay, fine. There. What time is it? Almost 10. So this is the resultant vector. So that is the result of u minus v or u plus negative v. So I'm going to put these closer so that it's obvious what's going on here. Oh, both pieces. There we go. There we go. And you guys come with me. Go there. Now, there's one way we can do this. It is not the only way that we can do this. And so another way that it can be done, although I almost have to look it up every time, I will always do it like this if I'm doing it geometrically. But here's another way we can do it. So grab this. And again, pull out my u and v vectors and make clones of these guys again. So put them over here. Come here. Stop that. Why are you doing that? Okay, here it is. And there's my v vector. Clone that. Lovely. Bring it out over here. Now, if I do it like this, the result's not right? But if I put them head to head, and if I go from the tail of the first vector to the tail of the second vector, look what happens. Okay, I'm going to grab this, and I'm going to see this, and I'm going to make it that same, I think, green color. Is that it? Maybe. I don't know. And look, if I go like that, this is still the same vector. These are equal vectors because look, if I make a clone of this, now you have to forgive that it's not going to be perfect, but if you look there, pretty much the exact same vector, right? So there's another way we can do it. You can put them head to head and go from tail to tail, but then you have to pay attention to the order because you've got a tail here and a tail here, and you might get it in the wrong direction. You might have the head of this vector down here, and then you have the opposite vector. You do not suffer that consequence if we add the negative. So I would highly encourage you to always add the negative. Is it feasible to do like this? Sure it is. But it requires that you remember things, whereas this just makes sense, okay, to me. I'll support you either way, but know that in class with you, if you were ever with me, I would never, ever demonstrate this again. It would always be done like this. And I try to, I cast my mind back to university. I don't remember. Actually, I'm not even sure if I was ever even taught this in university. This is something I've seen in the textbook. I'm not a fan. Okay, lovely. So that's vector subtraction. So let's look at some special cases. Am I on a pen? No, here we go. What about this case? How about if we had vector u minus vector u? What do you suppose that would equal? What is your instinct? Okay, write something down. So it might not be what you would think. I think most of you are probably going to think, if you've not been doing vectors very much, you might think, oh, the answer is 0. And while that makes a ton of sense, because u minus u, what's left? Well, nothing. There's some weird rules about vectors. If you add two vectors, the result will always be a vector. If you subtract two vectors, the result will always be a vector. This is not a vector. It is a scalar. So it seems like a really pedantic, meaning, overly focused on nitty-gritty, stupid details, which is true, but to be consistent, we have to make it the 0 vector, because vector addition and subtraction always results in a vector result. Now, reaching forward, the interesting thing, or the peculiar thing, I guess, is that vector multiplication, remember, there are two of them. One type of vector multiplication results in a scalar, and one type of vector multiplication results in a vector, which sounds ever so confusing. And frankly, to some extent, it is, but we'll get there. Okay. So, interesting thing about the 0 vector, because that's what this is right here. This is the, and I'm going to write that in there, I guess. This is the 0 vector. Okay, 0 vector. 0 vector. 0 vector has a magnitude of, well, unsurprisingly, 0. So that would be written, right? This is how we would write that. We would say the magnitude of the 0 vector equals 0. So the 0 vector has a magnitude of 0, i.e. like that, and has no direction. Okay, so the 0 vector has a magnitude of 0 and has no direction. So you think, well, what is even the point? Well, I mean, the point is that it needs to be consistent. For a system in mathematics to be consistent, it needs to be consistent across the board. And if we add and subtract vectors and get a vector result, that's got to be true all the time. So we can't just have 0. It's got to be the 0 vector. And I'll bust you on that if you didn't do the vector notation on that thing. So that's our first day of vectors. What I'm going to do now is I'm going to give you some homework questions to practice. Again, at whatever pace you feel like doing them. I'm going to assign a lot of them because some of you are going to need a bunch of practice and some of you are going to be like, this is old hat. So, it's up to you to decide how much of this you need to do. But I'm going to say that it is going to be on page 279, numbers 4 and 9, and then page 290. And it's going to be numbers, 1, 3, 5, 7, 9, 11, and 12. Okay. Do as much as you need to feel comfortable. For those of you who've taken physics and played with vectors before, that may not be very many. For those of you new to this, some of you might need to do a bunch to feel comfortable about it, and some of you might not need to do all of that many. Okay. Thanks. Have a lovely day.